So in the last tutorial, we saw that we can create objects that inherit from other objects, but we also saw that that was it was definitely a manual process. My general rule on programming and programmers is that we're all super lazy, and if something is tedious, that there is probably a better way to do whatever you're trying to do. And if not, you should make a library because the rest of us are lazy. Larry Wall's 3 attributes of a programmer, which is laziness, hubris, and impatience. I think that is definitely true and applies in this case. So in JavaScript, we actually have constructor functions. Well, we have functions that we can use as constructors, and I will get really pedantic about that in a little bit. But we have these functions that we can use to construct objects. This is useful in a case when we want to create a bunch of similar objects that share the same functionality, which is kind of the theme that I've been harping on this entire time. Careful readers might notice that constructor functions, or using functions as constructors, predates all of this object.create tomfoolery that I went over in the last video. I know, I don't care. I get to choose how I want to explain stuff. And so we did it out of chronological order, like some kind of Quentin Tarantino movie. These are definitely kind of the OG way of doing it, but we're going to explain them second. It is not wrong to think of constructor functions, or functions we use as constructors, as little factories that spit out a given type of object. So let's start out super simple here. We're going to create a constructor function. Constructor function it's just a function. There's nothing special about it. So we can say function Koopa Troopa, and you might notice oh, he's using a capital letter. I'm just using that because it's convention. It doesn't actually mean anything. I could create a constructor function with a lowercase k if I hated myself and all of my coworkers and future coworkers, but I don't, so I'm going to use a capital letter. And we'll get into why later, but it's just basically a convention that if you plan on using this as a constructor function, then you go ahead and start it with a capital letter for reasons that we'll get into. So Koopa, and I'll just say that is a new Koopa Troopa. I think I mentioned in the very first video in this little series here that an object literal was very similar to writing new object. And so to create a new Koopa Troopa object, we just type in this new keyword. And this will call that function as a constructor function. So now what we can do is we can expect that a Koopa is an instance of the Koopa Troopa kind of constructor that we had before. In the same way that we could expect that an object literal, or any given object, is an instance of object. And that's actually true. We can also say that it's an instance of Koopa Troopa, but it's also an instance of object as well. So both of those things are true in this case. As I mentioned before, if we forget the new keyword, things are going to go slightly poorly. They're not going to go really poorly in this case, because if you look on line 3, my current Koopa Troopa constructor function doesn't do a lot, but the more that it does, the more poorly it can go, and we'll take a look at that later. Let's actually grab lines 3 and 4. And in this case, we're just going to forget the new keyword. And we'll just say, hey, call the Koopa Troopa function. Now, if you look on either line 3 or 11, your choice, we can see that that function doesn't do anything. And in JavaScript, if you do not have a return statement in a function, it returns undefined. So instead of constructing a Koopa Troopa object, it is going to be undefined, which is not what we wanted, which is a slightly squirrely problem that we're going to have. And we will fix it later, I promise you. Not in this video, but we will fix it later. You have to keep watching. And we'll come up with a solution. We'll see other ways around it, but this can be slightly problematic. So if you're going to use a function as a constructor function, you need the new keyword, because there's nothing about that capital letter that makes that constructor function special in any way, shape, or form. It's us invoking it with that new keyword. So in JavaScript, not everything is an object. Strings and numbers and booleans are not objects most of the time. Some of the time, it's not important. We'll talk about it later, I promise you. However, anything that is a little bit more complicated, arrays are actually objects. Just the keys are the number of where it is in the array. Functions are also objects, which is, kind of a little bit unexpected if you didn't already know that, but a function is an object, and it inherits in this case from object.prototype. So let's just verify that with this test right here. And we can see that our little Koopa Troopa function works with object.getPrototype of, and that its prototype is function.prototype. So it stands to reason that if functions are objects, that they can also have properties and values just like any other object. And that is definitely true. That's going to kind of like get us into a little bit of the squirrelier part of this, where they can be called like a function, either with the new keyword or without it, as we saw in the previous test. But they can also have properties or keys and values just like any other object. So let's take a look at our little Koopa Troopa function over here, and I'll kind of bring it into existence. Now, it is an object that has a bunch of properties actually out of the box. There are ways to make your properties a little bit more hidden, right? So if I did like a object values with Koopa Troopa, or actually let's do object.keys, right? For all the keys in this Koopa Troopa object, you see I don't get any. Now, that's kind of a lie. You can hide them, and maybe in a future video, I'll show you how to like hide properties and make them the ones you can enumerate over, like in a for in loop, and which ones you omit, so on and so forth. But let's, for now, just look at kind of the secret way to get around that, which is get own property names, right, for our Koopa Troopa. And we'll actually find out that it does. Oh, look at that. It does, in fact, have some properties on that object. All right, length, just to be clear, is the number of arguments that it takes. So in this case, like it would be 0, since if you look at Koopa Troopa, it's not taking any arguments. Name is the name of the function. In this case, it is named Koopa Troopa. The one that we care about on the very end there is prototype. Prototype, the prototype property of the Koopa Troopa function is not its prototype. As we saw in the previous test, Koopa Troopa's prototype is function.prototype. This is where words get really hard and it gets kind of tricky to explain things. Koopa Troopa, the function, is a object and it has this property called prototype. And if we look at that real quick, assuming that I remember how to type, we can see that it's an object that only has this constructor property on it. And that constructor property is in fact also Koopa Troopa. So Koopa Troopa has a prototype property that is simply an object that has a constructor property that kind of points back to Koopa Troopa. So it's kind of like the circle of life right there. It's a cyclical reference, but it is not the prototype of Koopa Troopa. We can actually prove that out in a test. So let's prove that out. Now, the previous test shows us that the prototype for Koopa Troopa is function.prototype, but let's just be super thorough and also say that it is not Koopa Troopa.prototype. It's not its own prototype property. So we'll just expect that object.getPrototype of, getPrototype of Koopa Troopa is not to be Koopa Troopa.prototype. So that is also true. It has a prototype property. We can even write another test to verify that. It should have a property called Koopa Troopa.prototype. I can type when I'm not recording, when people aren't going to watch me type, I promise you. But typing and talking, real hard. So we can then expect that Koopa Troopa.prototype to be defined. So it exists. Oh, it is not defined. Troopa.prototype. Let's see. Oh, Koopa Troopa is not defined in this case. So we can see that Koopa Troopa.prototype does exist, but it is not the prototype of that Koopa Troopa function. It is simply a property on there, which raises the question of what is it used for, and we'll find that out next. The other thing that we'll go and validate is that Koopa Troopa.prototype is just an object that inherits from object.prototype. So let's go and validate that as well. So Koopa Troopa.prototype, we'll do object.getPrototype of. Object.getPrototype of Koopa Troopa.prototype is just object.prototype. You see that is also true as well. So why does any of this exist with the prototype chain? So let's add a little bit more color to that Koopa Troopa function that we saw before. So we'll say Koopa Troopa. And in this case, we're just going to try to keep it as simple as possible. We'll say, hey, it's going to take a first name argument. Again, it's just a function, so this is just something getting passed in. And what we'll say is we're going to take that first name and assign it to the first name property of the object that Koopa Troopa is constructing. So it looks repetitive, but it's taking this argument and assigning it. This, in this case, and we'll get more into this in a later video, but this, in this case, is the object that the Koopa Troopa constructor function is constructing. So it's going to be our brand new Koopa Troopa at this moment is called this. So we'll say whatever the first name that got passed as an argument, set it as the first name property of the Koopa Troopa that we are constructing. Now I could also do something along the lines of this dot full name, and we would need some way to generate that. So that should be like the first name plus Koopa as the last name, because I assume that's what the last name of any given Koopa Troopa is. Like, really, as I'm talking right now, I'm not confident in any of that, but let's go with it. And that will return whatever. So we'll say this dot first name Koopa, right? So it'll kind of dynamically generate it for us. Now we could actually set it in this case as well, but I'm trying to make a larger point here. And we could create a whole bunch of Koopa Troopas now using new Koopa Troopa. Now the problem here is if I created like 1,000, a million, a dillion Koopa Troopas, I would be creating 1,000, a million, or a dillion of these full name functions. And it's going to work the same for every Koopa Troopa. Each Koopa Troopa might need to hold on to its own unique first name, right? Some of them might be named Howard, another one might be named Beatrice, so on and so forth. With 1,000 of them, they could have 1,000 different names. So it makes sense for the individual Koopa Troopa to hold on to its first name. But the act of just tacking on Koopa onto the end, that is something that they should all know how to do, which means we should move it to the prototype of what it means to be a Koopa Troopa. And that way we're creating one of these functions instead of 1,000. So I will go ahead and just grab this function right here and all of this, and I will say Koopa Troopa dot prototype dot full name equals that function, right? And this syntax with the backticks and the curly braces and the $sign is just a way to interpolate this value into a string. If you don't like this, you can also do like plus space Koopa. That'll work the same way. Whichever one makes you happier is fine with me. You can create like a dillion Koopa Troopas each with their first name, and they will all know how to come up with their full name because they don't have a full name property individually themselves, but they will look up to Koopa Troopa dot prototype, which is just a regular object, to figure out how to put together a full name by tacking Koopa onto their first name. Let's start by writing a test to make sure that like the first name that I pass into that function gets put on to the instance of the Koopa Troopa. Just an initial test to make sure, like literally to make sure anything works, to be honest. We'll say new Koopa Troopa, and let's call this one Howard, right? And then we can expect that dot first name to be Howard. Nothing special in this test, just making sure everything works. Great. And we want to assume that like it has that like that belongs to that given Koopa Troopa. Again, a very, very simple test rather. To its own property. All right, and so this is just to assume that it is literally on that instance as well. Koopa dot has own property first name to be truthy. Great, so that works as well. We also want to make sure that it is inheriting that ability. We want to make sure it's inheriting that full name property as well. So we're going to write two more tests they're similar to this one, except this time the full name should not be part of that individual Koopa Troopa. It should be up the chain, and it should in fact work. So we'll go ahead and we'll grab this test. So we'll grab that first test and we'll say it should be able to come up with its first name. First name, or full name rather, full name. It wants to come up with its full name. And so we'll have that new Koopa Troopa, which is Howard, and we'll say full name should be Howard Koopa. All right, that is not true because we didn't actually call the function. We just referenced the function. So now it is absolutely true. And we'll grab this test just to verify our assumption. Should not have full name as part of the instance. So that should be on Koopa Troopa dot prototype. And like we saw the code, we basically know that it is, but we're writing tests because we're trying to be thorough here. We're trying to make sure that I am not fibbing to you and that I am being honest. False. I always want to put an E in falsy. All right. So first name, definitely on the instance of Koopa Troopa. Full name, definitely not there. It's on the prototype chain, so they can all share the way that a given Koopa Troopa figures out its full name. All right, so what did we learn today? We learned that functions can be used like functions, or they can be used as constructors to create objects with a given inheritance chain. The new keyword is just a thing that lets that function know that you intend on creating objects rather than calling it as a regular function. Functions themselves happen to be objects. Those function objects all inherit from function.prototype, but they also have a prototype property that's just an empty object. That empty object is used as the prototype for all the objects that get spit out of that function when it's used as a constructor. This is a good place to put anything that should be shared by all of the instances that pop out of that little constructor function factory.